we have a function, rational function here, x cubed plus 1 over x squared minus 4. In order to graph this, the first thing we would like to do is factor it completely. Our denominator is a difference of squares. That factors as x minus 2 times x plus 2. The numerator is a sum of cubes, and that's a little bit less familiar to most people. The formula for sum of cubes is that a cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. And x cubed plus 1 is the same thing as x cubed plus 1 cubed. So a is x and b is 1, and we just plug it all in there to get our factored form. So x plus 1 times x squared minus x plus 1. Okay, and this quadratic in the formula for the sum of cubes we know is always irreducible. It will not factor. Now, we don't have any common factors here, so there's no reducing to be done. So we're ready to jump right into getting some intercepts. Okay, our x-intercept we get by setting the numerator equal to 0. So I take x plus 1, set that equal to 0, and that gives me x equals negative 1, and that has a multiplicity of 1. And the x squared minus x plus 1, because we know that's irreducible, we know that there's no real number for which it will equal 0. So we don't need to worry about setting that equal to 0. And we need our y-intercept. We get the y-intercept by plugging 0 into our function. So f of 0 equals, and I'll plug it into this non-factored form, and that just gives us 1 over negative 4. And we can find our asymptotes. For our vertical asymptote, we find the zeros of the denominator. So if we set x minus 2 equal to 0, that gives us x equals 2. And that 0 of the denominator has a multiplicity of 1. And if we set x plus 2 equal to 0, we get x equals negative 2. And that 0 of the denominator also has a multiplicity of 1. Horizontal asymptotes we only get if the degree of the numerator is less than or equal to the degree of the denominator. And we don't have that here, and so that means there is no horizontal asymptote. Slant asymptotes we get if the degree of the numerator is exactly 1 more than the degree of the denominator. And in this case, it is. Okay, the degree of the numerator is 3, which is exactly 1 more than 2, the degree of the denominator. So we do have a slant asymptote. In order to find the slant asymptote, we do polynomial long division, where we divide that. So x cubed divided by x squared is x. And multiplying the x by the x squared minus 4, I get x cubed, and then minus 4x. And I'm going to go ahead and move this over a little bit so that it's looking like it's lined up. And we subtract, and with x cubeds cancel. There's nothing here, and then we subtract negative 4x, so that gives us a positive 4x. And then we have the plus 1. Okay, this has a degree less than the x squared minus 4, so we're done with our division. The division gives us x plus, and then 4x plus 1 over x squared minus 4. For the slant asymptote, the equation of the slant asymptote is simply that quotient. All right, so y equals x is the equation of our slant asymptote. All right, let's go ahead and graph now what we have. We have an x-intercept over at negative 1. So there's a negative 1. I've got that point there. We have a y-intercept of negative 1/4, which is about right there. We have a vertical asymptote over at x equals 2. And we'll go ahead and do that in red so that it stands out in contrast to our graph. And we also have one at x equals negative 2. So So those are our vertical asymptotes. And then we have a slant asymptote of y equals x. So we go ahead and graph y equals x. All right. So now we are ready to start drawing. We have here a point below the x-axis, so we can kind of work with that point to start drawing. From this point, as I move to the right, I know I can't go up because I can't cross the x-axis over here. So to follow my vertical asymptote at 2, I have to go down. Oh, let's do it in black. So we go down to follow that asymptote. Then I come to this 0 at -1, and when I get to that -1, I need to know the behavior of the function. So I go to where I found that, which was the 0 of the numerator, and that had a multiplicity of 1, which tells me that my graph crosses the way a line would there at -1, and then I need to follow my vertical asymptote. All right, now, as I jump across this asymptote, I need to know what happens. At x equals -2, that 0 had a multiplicity of 1, which is odd. That tells me that the behavior on the left is different. So it's going up on the right, which means it's going down on the left. And then I need to follow this slant asymptote. So I just need to come up around and then follow that slant asymptote. Over here, after to the right of x equals 2, I need to know what happens as I cross this asymptote. So on the left of x equals 2, it's going down. X equals 2 had a multiplicity of 1, which is odd, so the behavior is different on the right. So it's going down on the left, which means it's going up on the right. Oh, let's add black. And then, of course, I need to follow my slant asymptote. So there's a sketch of this rational function.